Imagine for a moment, uh, what if the universe isn't just something we observe?
Mm,
What if, in some deep way, it observes itself?
right.
And what if even something really tiny, really weird like a quantum particle could actually be part of that? Could be an observer.
That's the core idea we're diving into today, isn't it?
Exactly. We're taking a deep dive into quantum tunneling, but not just as, a physics thing.
No, seeing it as a type of observer.
Yeah, and how this fits into this unique framework from our source material, Foundations of Hyperspace Physics, something they call the observer group set.
It's a really interesting concept.
And for you listening, think of this as a shortcut, maybe, to a pretty cutting-edge idea. It really stretches the definition of observe.
It absolutely does. Offers a whole new angle on how reality might actually be put together.
What's so fascinating, I think, is that this isn't just about, subatomic particles doing strange things.
No, it's much more fundamental. It kind of challenges our basic intuition,
Oh.
Well, the idea that observation isn't always something conscious, something we do from the outside, but maybe it's something intrinsic, woven into just how things happen naturally.
Okay, let's ground that a bit. Quantum tunneling. People might know the basics.
Yeah.
It's that weird quantum effect, right?
Right, where a particle seems to pass through a barrier.
Yeah, even if it doesn't have the energy, classically speaking, to get over it, like phasing through a wall.
Exactly. And it's a key moment, that transition. You go from this fuzzy, probabilistic wave
To a definite particle.
Yeah.
In a definite place.
Precisely. And the core idea from the source material is that this process can be seen as a form of observer.
Because it forces a choice.
In a way, yes, because it involves that transformation from the wave function to a specific localized state. That's what the source calls symmetry reduction.
Or coherence reduction.
Coherence reduction, yes. You're basically reducing the possibilities, narrowing it down to one actual outcome.
Wow. Okay, so a physical process itself, not a mind or anything acting like an observer, that does change things.
Yeah, it really does.
So how does quantum tunneling fit into this observer group set idea from the source?
Well, it connects in a few key ways. First, it's seen as a symmetry reduction observer.
Okay.
The act of tunneling itself breaks the wave function's symmetry. It moves from that spread out superposition
To a single point.
to a localized particle, yeah. Then second, it's a coherence reduction observer. Meaning the process itself, the interaction with the barrier, is seen as the mechanism that inherently reduces that coherence, that wave-like nature. The system sort of selects a state because of the barrier. And third, they call it an intrinsic observer.
Intrinsic, meaning it just happens naturally.
Exactly. Tunneling is a natural process that does the job of observing without needing, a scientist with equipment.
So natural phenomena themselves have these observational properties built in.
That's the suggestion, yeah.
And the barrier, the wall, the particle tunnels through. It's not just a passive wall in this picture.
Not at all, no. The source sees the barrier as a crucial boundary condition. Or you could even call it a passive observer. It's what facilitates the transformation. Wave function meets barrier. Particle state emerges.
Right.
And this view really deepens the connection, doesn't it, between physical processes, symmetry, observation. It all seems linked.
It does. It highlights how the structure of the universe might be shaped by these abstract observational rules.
And it makes you think, right, if a simple barrier can trigger observation.
What else acts as an observer?
Exactly. What about other natural systems? What inherent observational stuff is going on everywhere?
That's a huge question. And it makes me think, what about other big quantum mysteries? Does this framework shed light on, say, the double-slit experiment?
Ah, good connection.
Because observation is key there too, but famously puzzling.
It is. And the source material specifically points out a striking conceptual parallel between tunneling and the double-slit.
Really? They seem quite different on the surface.
They do, but the underlying principles of observation, according to this framework, are remarkably similar.
Okay, how so?
Well, think about it. In both cases, you start with a coherent wave function, right? All potential.
Spreading out.
And in both, it transitions to a localized particle state, a specific outcome.
Right. In the double slit, the wave hits the screen and becomes a dot.
And in tunneling, the wave interacts with the barrier and becomes a localized particle on the other side.
So it's the same basic journey. Coherence to localization. Possibility to actuality.
Exactly. Guided by interaction with some external condition or context. the slits or the barrier.
And both involve that symmetry reduction idea.
Absolutely. And coherence reduction, too. With the double slit, if you observe which slit the particle goes through,
you lose the interference pattern.
Right. You break the symmetry of the two possible paths. You force a choice, coherence collapses.
And with tunneling,
the barrier does something similar. It interacts with the wave, forcing it to resolve its coherence, to become that localized particle. It reduces the symmetry of the wave function.
so the barrier is the observer in that sense.
Or at least fulfills the observer function, yeah.
Which really hammers home that idea of boundary conditions as observers, doesn't it?
It really does.
The slits define the paths. They act passively. The barrier interacts, forces the change. It's not necessarily about someone looking.
Precisely. The interaction itself is the key observational element.
Okay, and what about information? Is that involved too?
Yes, that's another parallel. Both processes can be seen as involving a mapping of information.
How?
In the double slit, the wave pattern itself, the interference, encodes information about the possibilities. Measurement then maps that potential information onto a definite position.
Okay.
With tunneling, the wave function sort of maps through the barrier, and in doing so, potential information gets transferred into the properties of the final localized state.
It's like information is being transformed by the process.
That's a good way to put it. There's an inherent information dynamic at play.
Now, the source mentions something called hyperfractal dynamics. That sounds complex.
It is a bit abstract, yeah. But the basic idea is, imagine the universe has this underlying pattern, like a fractal.
Repeating patterns at different scales.
Kind of, but maybe even repeating across different dimensions of reality. Higher dimensions we don't directly see.
Whoa.
So from this hyperfractal viewpoint, things like tunneling and the double slit are how higher dimensional coherence, this sort of underlying potential, gets resolved.
Into what we can see, our lower dimensional world.
See that observable states, yeah. It suggests wave-particle duality, coherence, observation. These aren't just quantum oddities.
They're fundamental, universal processes.
Embedded in the very structure of reality, maybe. Part of this hyperfractal nature.
That's a big idea. And it leads to some pretty deep philosophical points, doesn't it?
Absolutely.
Like first, observation isn't just something we do, it's fundamental. It emerges from interactions everywhere.
Right. It points to its universality.
And second, it really ties together the wave-like coherence and the particle-like localization. Breaking symmetry seems to create this interdependence.
Yes. The link is crucial. Potentiality and actuality are bound together.
And third, observation is fundamentally about information, transforming it.
Exactly. It's not just about position or momentum. It's about the flow and transformation of information itself.
If you connect all that, it really suggests a kind of deep unity, doesn't it?
It does. A unity in how the universe works, even in these seemingly passive interactions.
It reframes interaction as observation, in a sense.
That's a key takeaway, I think.
Okay, so if quantum tunneling acts as an observer, does that mean it's also doing a measurement? Are those the same thing here?
Ah, that's an important distinction the source makes. They're related, but not quite the same.
Okay.
For tunneling, just like for the double slit, perhaps, you can think of two different but connected roles, the observer function and the measurement function.
Observer function and measurement function.
Right.
So what's the difference in tunneling?
The observer function is basically fulfilled when the particle first encounters the tunnel, the barrier.
When it hits the wall, so to speak.
Exactly. The barrier provides the context. It challenges the wave function's coherence, introduces that asymmetry we talked about.
So the barrier is the passive intrinsic observer.
Yes. It initiates the conditions for localization. It sets the stage, but it doesn't by itself instantly make the particle appear on the other side.
Ah, okay. So that's the measurement part.
That's the measurement function, yes. That happens when the particle actually localizes on the other side of the barrier.
The moment it becomes real over there.
That's the point of collapse. The wave function resolves into a specific, definite state. It completes the process the observer function started.
And that localization is the symmetry reduction event.
Exactly, going from that probabilistic wave to a discrete particle.
So it's like a two-step process, almost, or a continuum.
More like a continuum, I think. Observation sets things up, creates the conditions.
Stromage is the coherence.
Right, and then measurement is the resolution. The final step where coherence is fully reduced into that definite, localized state.
So natural processes, like encountering a barrier, are observers.
And measurement is how those observations get resolved into tangible outcomes.
Oh. So just bumping into a barrier starts this chain reaction that ends with the particle popping into existence in a specific place. And you said localization is also about information reduction.
Yes, that's key. It's not just collapse. It's seen as a mapping of information.
From where to where?
From that higher dimensional coherent state full of potential down to a lower dimensional discrete measurable state. You're taking almost infinite possibilities and basing them into one actual result.
That's fascinating. And the source mentioned the tunnel as a resonance locus. What's that about?
Yeah, that ties into the hyperfractal idea again. The tunnel barrier is seen as a special place, a locus,
where these underlying coherence fields interact with the universe's structure.
Exactly. In a way that enables or triggers that wave-to-particle transition, like hitting a specific resonant frequency.
And the final localization, the particle appearing.
That might actually represent the collapse of some higher dimensional coherence into our familiar 4 dimensions of space-time.
That is quite a leap, as you say. But it pulls it all together.
It tries to, yeah.
So even passive things like barriers act as observers. Observation and measurement are linked but distinct.
Interdependent processes.
And measurement, localization, is fundamentally the act that makes potential actual.
That's the core philosophical implication. It brings potentiality into actuality.
What's really compelling is how this framework seems to bridge the really weird quantum stuff with a bigger picture of how reality emerges.
Exactly. It provides a potential unifying perspective. Reality isn't just static. It emerges through these interactions, these observations and measurements.
Okay, thinking bigger picture then. If this applies at the quantum level, what about us? What about science? When a scientist makes a measurement in the lab, are they just, passively watching? Or is something similar happening?
Well, according to this framework, something very similar is happening. Profoundly similar.
Really?
Yes. The sources draw a direct analogy. Measurement in science is like quantum localization.
How?
It's also about bridging potentiality, all the possible things you could measure, all the possibilities.
And actuality.
Yeah.
The specific result you get.
Exactly. Scientific measurement takes that vast potential information and localizes it, reduces it into a finite specific form, data points, numbers.
And once you have that knowledge, that localized information, like you measure the mass of something precisely.
Then it becomes solid ground, a basis for the next step.
Right, for more science or building technology or even refining your philosophy about it, it gives you something concrete.
Precisely. And just like the quantum examples, scientific measurement also involves symmetry reduction.
How so?
Think of all the possible values you could have measured, an infinite continuum, perhaps? Measurement reduces all those potential symmetries down to one specific result, your reading. It breaks the symmetry of possibility.
And coherence reduction, too.
Yes, it takes what might be an interconnected web of potential and isolates a specific phenomenon, making it measurable, discrete.
And this isn't just something humans do. This framework sees measurement as more fundamental.
Yes, that's a key point. It's presented not just as a human activity, but as a universal principle, a natural observer function that operates at all scales. It's suggesting that measurement is how the universe itself emerges into a knowable form.
It's how potential information becomes actual localized information.
Exactly. The source even uses this term, asymmetry resonance operator.
Okay, break that down. Asymmetry resonance operator.
Think of it like tuning a radio again. You have all this background noise, all frequencies. That's like the coherence, the symmetry. Right. The active measuring of tuning to get a specific reading creates a kind of resonance. It selectively amplifies one signal, one asymmetry.
Yeah, all the possibilities.
And resolves the coherence into that specific, localized knowledge, creating asymmetry from symmetry via resonance.
That really makes you think, doesn't it? If measurement is that fundamental,
it does.
What does that mean about our own role? When we observe, when we measure?
That's the profound question it raises, isn't it? How does it change our perception of ourselves within the universe?
Yeah. It implies measurement isn't just passive recording, it's participation.
In a very deep sense, it's the mechanism, the framework suggests, by which the universe's latent potential gets realized, brought into being, you might say.
It really highlights this tight link between the observer, the observed, and the knowledge that comes out of it.
They're all tangled together. Reality emerges through that interaction.
The source even calls measurement a creative act.
Yes, like the universe is constantly being shaped and reshaped by this interplay. Potentiality, observation, action. It's dynamic.
And they mention coherence engines. What's that?
Ah, that's another layer.
Yeah.
The idea is that measurement creates asymmetry, right? It breaks coherence. Coherence engines are conceptual systems or processes that work the other way. They try to restore symmetry, revert asymmetry back to coherence.
So there's a balance between breaking coherence measurement and restoring it.
Potentially, yes, a cosmic balancing act. And interestingly, they suggest measurement itself, by creating localized knowledge, might even have a coherence-restoring potential in the bigger picture.
That's a lot to take in. Okay, so wrapping up our deep dive today.
Mm-hmm.
We really wanted to understand quantum tunneling not just as this weird physics trick,
Right.
but as a window into how observation itself might work, fundamentally.
And I think we saw how the idea of observer gets expanded here, didn't we?
Definitely. It's not always us looking from the outside.
No, it can be an intrinsic process, a boundary condition, part of the system itself.
And those parallels between tunneling and the double slit.
Wow. Striking, aren't they? Both seem to point to these same underlying principles: symmetry reduction, coherence reduction, information dynamics.
It suggests a real unity at the quantum level. And then expanding that idea, realizing that even scientific measurement seems to echo this deep universal process, this localization.
Bringing potential into actuality.
Yeah, it really paints a picture of profound interconnectedness, doesn't it? Physical processes, information, reality itself, all woven together.
It certainly does. It offers a very different perspective.
So here's a final thought for you to maybe mull over.
Okay.
What if the very act of your attention, your everyday observation of the world, what if it isn't just perceiving what's already there? What if, in its own subtle way, it's continuously shaping the potential, influencing what actually becomes real around you?
A provocative thought indeed. Something to consider.